In this video, we're going to introduce the naming of hydrocarbons, of just pure alkane hydrocarbons. So what is an alkane hydrocarbon? What does that mean? Well, if you have just carbons and hydrogens, so C2H6, or CH4, or C3H8. So a few different ways to see that drawn: chemical formulas, skeletal drawings, expanded drawings. The idea is they are just chains of carbon filled with hydrogen. These are alkanes. And so if you think of oil, this is generally what you think of: long hydrocarbons. So usually gasoline is in the 7 to 12-ish carbon length range. Oils tend to be much higher than that. You can get oils at the 22 and 24. So this is the general idea of them. Well, how do you differentiate them? How do you discuss them? We're going to introduce terms here that will be used throughout the entirety of organic naming. And so we got to introduce carbon chain naming. Carbon chain naming is a series of names largely unique to chemistry that tell us how long the carbon chain is. And so if you have something that is one carbon, so numbers of carbons, if you are one carbon, it uses the term meth. If you are two carbons, it is eth. 3 carbons is prop. 4 carbons is bute. 5 carbons is pent. 6 carbons is hex. 7 carbons is hept. 8 carbons is oct. 9 carbons is non, and 10 carbons is dec. And we'll leave it there. We won't use any more than that for our purposes. But this series of naming elements gets used repeatedly through organic chemistry. So it's an important list to remember. Well, how do we use it? Let's go back to CH4. We said this was an alkane. Names in organic chemistry are composed of several parts. And so we usually have the longest carbon chain, or the main chain, followed by a functional group. A functional group is a particular arrangement of atoms that do particular types of reactions. So an alcohol, or an amine, or an acid, they are types of functional groups, and we'll discuss them all individually in time. For this example, if we are nothing but carbons and hydrogens, and all of your carbons are single bonded, so alkanes, carbons are single bonded to other carbons. If that's the case, you are an alkane. So you have nothing but carbon and hydrogen, and all your carbons are single bonded. What you do to name them is you say, what is my longest carbon chain? Well, for example, right here, I only have a single carbon. So my longest chain is 1. My longest chain is meth. And so you say, oh, the name for this, it's meth for its main chain. And then for the functional group, every functional group has its own suffix. For alkanes, that suffix is ANE. And so our meth becomes methane. We had the carbon chain length, and we had what the group we were talking about was. Well, we can slide this down Let's try that for another carbon length. Let's say 2 carbons. So again, I'm all carbons and hydrogens. My carbons and carbons are single bonded to each other. This is an alkane, but it is 2 carbons long. In this case, we move down to the eth for being 2 carbons long. So the start of the name is eth, and because it is still an alkane, it becomes ethane. Eth for the carbon length, ane because our functional group is alkane. It's just hydrocarbons and carbon-carbon single bonds. Well, we can continue this all the way to the bottom if we want. Do a few more. If I am 3 carbons long, so 1 carbon, 2 carbon, 3 carbon, well, that's a prop. So the naming would be prop and then ane. If I have one that is 6 carbons long, so 2, 3, 4, 5, 6, here's a skeletal drawing of a 6 carbon long chain. All the carbons are single bonded to each other, and, well, they're filled with hydrogens that we don't show in the skeletal drawing. So this is 6 long, this is a hex, and then it's an alkane, it's a hexane. And so there's heptanes and octanes and nonanes and decanes and butanes and pentanes. Natural gas is the one we're most familiar with, methane. It is CaH4. It is a single carbon chain, then filled with hydrogens. This is where the name methane comes from. It tells you how long the carbon chain is and what type of things are attached to it. As we get to other functional groups, we will swap out the ending for a large variety of different suffixes, but this is how we do alkane naming. So let's give it a practice. Name these 3, and then come on back. All right. Well, if we give it a shot, let's start with our first skeletal drawing. The end points and the intersections are carbon. And so this is 4 carbons long. 4 carbons is a bute. And so this must be a butane. Butane. This is what's in, say, a Bic lighter. Butane is the standard gas in handheld lighters. It burns quite easily. If you put it under a little bit of pressure, it'll turn liquid, which is why it's liquid in the lighter. But as soon as you open the container and it can escape, it turns into a gas. Octane. Well, oct was our term for 8. And ane, again, hydrocarbons. So this must be an 8 carbon chain. So 2, 3, 4, 5, 6, 7, 8. We often just draw them zigzag because that's the quickest and easiest way. And, well, being an English individual, we write from left to right, and so we tend to draw them this way. And we see that there are 8 carbons in it. If we go up to our upper right molecule, there's 1, 2, 3, 4, 5, 6, 7, 8. There's actually 8 carbons in this. They're all single bonded to each other. This is also octane. It looks visually different, but that's irrelevant. In the end, if it's just a chain of carbons, it's a chain of carbons. There's no reason they have to be perfectly zigzag left to right, like our lower left one. It's just convenient to put them in a nice line, but they can take all sorts of shapes. You could easily have this be 2, 3, 4, 5, 6, 7, 8. You could make it sort of ring around on itself. It's just like holding a piece of string. You can pull it straight, you can kind of loop it, you can twist it around. It doesn't really matter as long as it doesn't cross over. It's still just one long, continuous jointed line of carbons connected to each other. Well, that's the basics of naming alkanes.